Welcome to the DIY Honda Garage channel. The DTC P0455 indicates a significant leak in the evaporative emission control system, EVAP, of the Honda Pilot, model years 2016 to 2022. This system plays a crucial role in capturing fuel vapors from the fuel tank and preventing them from entering the atmosphere, which is essential for meeting environmental regulations and maintaining fuel efficiency. The leak could be due to various components within the system, including hoses, valves, or the fuel tank itself. The DTC can also appear alongside P0456, which represents a smaller leak detected. Before troubleshooting, it is important to gather diagnostic tools, including a vacuum pump and gauge, to accurately assess the system's condition. Excessive vacuum or pressure tests can damage components, so adhering to specified limits is critical for safe and effective diagnostics. The Evaporative Emission Control System, or EVAP, is designed to trap fuel vapors from the fuel tank, sending them to the engine for recombustion. If DTC P0455 triggers, it signals that there is a significant leak detected in this system. The main components involved include the EVAP canister, vent shut valve, purge valve, fuel tank vapor recirculation tube, and the fuel tank pressure (FTP) sensor, which monitors system pressure to identify leaks. The location of these components varies. For instance, the EVAP canister is usually located in the rear of the vehicle, near the fuel tank, while hoses run throughout the vehicle, connecting to the fuel tank. It's essential to inspect these components closely to diagnose the issue effectively, as a large leak can significantly impact vehicle performance, fuel efficiency, and emissions control. There are several possible causes that could lead to DTC P0455 activating. Firstly, a blocked or restricted vent hose to the EVAP canister can prevent the proper movement of vapors, leading to a false large leak detection. Next, the fuel tank vapor recirculation tube may become damaged or disconnected, resulting in loss of integrity in the system. Additionally, the EVAP canister purge valve can become faulty, allowing vapors to escape instead of channeling them back to the engine. Other potential causes include an issue with the FTP sensor itself, bad connections at the various terminals, and wear or damage to the EVAP canister. Diagnosing these causes is essential for effective repair and ensuring that the vehicle meets emission standards. When the DTC P0455 is triggered, the most noticeable symptom is often the illumination of the check engine light, CEL, on the dashboard. This warning serves as an alert that there is a significant issue within the EVAP system. Another common symptom is decreased fuel efficiency, as unburned fuel vapors that should be recycled could interfere with air-fuel mixture ratios required for optimal engine performance. In some cases, there may also be a noticeable fuel odor, indicating leakage of vapors. Depending on the severity of the leak, these symptoms can vary. Some drivers may not notice a significant change in performance initially, but prolonged issues can lead to more extensive system failure, heightening the importance of timely diagnostics and repairs. To begin troubleshooting DTC P0455, the first step is to verify the problem by turning the vehicle ignition to the on position without starting the engine. This allows the vehicle's systems to come online, enabling the scan tool to communicate with the onboard computer. Next, use the HDS, Honda Diagnostic System, to clear any existing diagnostic trouble codes. This action will reset the system so that you can assess the current state without the influence of past codes. After clearing the codes, turn the vehicle off and back to the on position. Select the EVAP test from the inspection menu of the HDS, followed by the function test. Observe the results carefully. If the test result comes back as okay, the issue may be intermittent. However, if you confirm a failure, proceed to the next troubleshooting step. In step 2 of the troubleshooting process, focus on the EVAP canister vent hose. Begin by ensuring the vehicle is turned off to prevent any electrical issues while you inspect the components. Carefully check the vent hose for any signs of blockage or restrictions. This could be caused by debris, kinks, or physical damage. If a blockage is found, you will need to remove it carefully to restore proper airflow. In cases where the hose appears severely restricted or damaged, it may be necessary to replace it entirely to ensure that no further issues will arise in the EVAP system. Once you clear or replace the vent hose, proceed to the next troubleshooting step to verify further system components. The third troubleshooting step involves a visual inspection of the fuel tank vapor recirculation tube. Begin by looking for any poor connections or visible damage at both ends of the tube. This tube typically connects the fuel tank to the EVAP system and is vital for recycling vapors. If the tube is found to be damaged or connections appear loose, they need to be fixed. A proper connection is essential for ensuring that vapor flow is not interrupted. If necessary, the fuel tank vapor recirculation tube will need to be replaced completely. Once this inspection is complete and any necessary repairs are made, you can proceed to the next step in the diagnostics process. In step 4, focus on checking the EVAP canister purge valve. Begin by disconnecting the vacuum hose from the valve located in the engine compartment. Next, connect a T-fitting along with a vacuum gauge and vacuum pump, ensuring it is properly secured to avoid leaks during testing. Once everything is set up, slowly apply approximately 2 kilopascals of vacuum to the hose. It is important to monitor whether the vacuum holds steady for 1 minute. If the vacuum holds, this indicates that there is no leak within the EVAP canister purge valve. However, if the vacuum fails to hold, then the valve itself is likely faulty and will need to be replaced. Completing this step will help confirm or eliminate one potential cause of the DTC. Step 5 involves determining where the failure may reside by checking the EVAP canister vent shut valve or other components. Disconnect the fuel tank vapor recirculation tube from the EVAP canister and plug the canister port to prevent any escaping vapors. Then, remove the vacuum gauge setup and reconnect the vacuum pump gauge to the vacuum hose leading to the EVAP system. Proceed to turn the vehicle ignition to on mode and select the EVAP test from the inspection menu. Following this, choose the EVAP CVS on setting in the HDS to perform the test while you carefully apply vacuum until the FTP sensor reads about 1.90 volt. You should closely observe any changes in voltage over the next minute. An increase greater than 0.2 volt indicates a functioning system, while no change suggests a problem requiring further diagnosis. Continuing to step 6, you will need to conduct an operational check of the EVAP canister vent shut valve. Begin by selecting the EVAP test option in the HDS menu and change the setting to EVAP CVS off. Disconnect the vent hose from the canister, plugging the open port to avoid vacuum loss. Reapply vacuum to the hose until the FTP sensor reflects the specified reading. Monitoring the sensor for any changes over the next minute is essential. If the voltage increases significantly, this indicates that the EVAP canister vent shut valve is functioning correctly. If the voltage does not rise, the valve is likely defective and should be replaced to restore proper EVAP operation. Step 7 requires a thorough inspection of the EVAP canister purge line. Start by turning off the vehicle to prevent any electrical hazards while checking the components. Look closely for any poor connections or visible damage along the purge line that connects the EVAP canister to the purge valve. It is essential to ensure there is no wear or tear that could compromise the integrity of the system. If found, both the EVAP canister purge line and the canister itself may need to be replaced to ensure the system can properly manage vapors. It's important to address any issues at this stage to prevent recurring problems related to the EVAP system performance. In Step 8, focus on the visual inspection of the fuel fill pipe and fuel vapor return pipe. Begin by turning the vehicle to the on mode to have the systems activated for evaluation. Select the EVAP CVS off setting within the HDS menu for this test. Carefully examine both pipes for any signs of poor connections, cracks, or damage that could contribute to a leak. Addressing issues with these structural components is critical, as they play a vital role in the overall management of fuel vapors within the EVAP system. If any damage is present, those components need immediate repair or replacement to maintain the system's function and prevent additional diagnostic trouble codes from occurring. Step 9 involves a check of the shutoff valve functionality. The first action is to turn the vehicle off and proceed to remove any misfuel inhibit device that could interfere with the inspection process. Focus on observing the shutoff valve flap to confirm that it is in a closed position. A closed flap is essential to prevent fuel from spilling and maintain proper pressure within the fuel delivery system. If the flap is found to be open, immediate replacement of the main flap unit is necessary to ensure the system operates correctly and that no leaks are present. Addressing this component will aid in resolving the larger issues related to the DTC being investigated. In the final troubleshooting step, check the shutoff valve seal and its mating surface for integrity and proper fitting. Begin by examining the flap seal on the shutoff valve, looking for any signs of damage, wearing, or missing segments that could lead to pressure loss or allow fuel vapors to escape. It is crucial that the seal maintains tightness against the mating surface to prevent leaks. If any issues are found, replacement of the main flap unit becomes necessary to restore proper function. Additionally, make sure to check the O-ring and fuel tank, as they can also impact the performance of the entire EVAP system. Finalizing these checks will help confirm whether the issue causing the DTC P0455 has been fully resolved. After completing all troubleshooting and repairs for DTC P0455, it's crucial to conduct final verification of the system. Start by running the EVAP tests once more using the HDS to ensure that no diagnostic trouble codes remain present in the system. This helps confirm that the repairs made were successful. Additionally, check the functionality of the entire EVAP system to verify that it operates correctly under various conditions. Ensure that the fuel system operates within the prescribed pressure and vacuum limits specified by Honda to avoid future complications. This final verification step is essential, not only for determining the effectiveness of the repairs made, but also for ensuring the long-term operation and compliance of the vehicle. Preventive maintenance is key in avoiding recurring issues with the EVAP system. Regular inspections of the various components, including hoses, valves, and the fuel tank, should be part of routine vehicle maintenance. Keeping records of any repairs made can also help track the performance of the EVAP system over time. Additionally, maintaining an appropriate fuel level in the tank, not allowing it to run too low, can help prevent unnecessary wear on the system, since higher volatility fuels can exacerbate leaks. If any leaks do occur, they should be addressed promptly to prevent further issues. ensuring that the system remains in good working order and compliant with emission standards. By practicing these maintenance tips, drivers can contribute to the longevity and efficiency of their vehicle's EVAP system. In conclusion, understanding and addressing DTC P0455 is critical for maintaining the efficiency and environmental compliance of the Honda Pilot from 2016 to 2022. The EVAP system's primary function is to capture fuel vapors and prevent their release into the atmosphere, aligning with regulations and improving fuel efficiency. A significant leak detected by this DTC indicates a need for thorough diagnostics to pinpoint and address the underlying issue. Whether it be a blocked hose, faulty valve, or damaged components, prompt attention to diagnostic trouble codes can prevent further issues down the line and enhance overall vehicle performance. By following detailed troubleshooting steps and implementing preventive maintenance, vehicle owners can ensure their EVAP system remains effective and reliable for years to come. Please like and subscribe to the channel. See you next time.